Welcome to lecture 6 of the course CS213 Object Oriented Programming of the Cohort University of Science and Technology. In this lecture we will continue our discussion of introduction to classes and objects. We will talk about how we can create classes and how we can use constructors to initialize objects for those classes, how we can use setter getter methods to try to manipulate and change the values for the variables of the classes, and we might also talk about the class variables and the class methods. The reference reading for this course is Java How to Program Early Objects version of the Detail and Detail series, and this lecture can be referenced with the chapter 3 of the book. You can follow the Java tutorials that are online for the classes and the objects that are available on the official documentation, or there are numerous tutorials that you can follow. So in our previous lecture we were talking about the accessibility to our variables inside the class, and we were able to access our variables from outside of the class since the default access to our instance variable is the package level access. So if two classes are within the same package and we do not specify the access level for our variables or methods, then we can access those variables or methods from the two different classes that are inside the same package. Java provides a number of access modifiers to set class level access, to set access levels for classes, variables, methods, and constructors. There are 4 levels, but we'll look at 2 at first. Members of a class that are declared with public visibility can be accessed from anywhere, and members of a class that are declared with private visibility can only be accessed from inside the class. We'll look at an example that how when we provide when we use these access modifiers, then how they can change the accessibility of our instance variables and our methods in the class. So as a general rule, we try to hide the data for our objects. No objects data should be declared as public. That means that we will try to declare our instance variables as private whenever possible, and methods are usually declared as public so that they can be invoked by the clients. Since we do not want to provide direct access to our data, then the methods that we use to manipulate that data or do some calculation on the data will usually be declared as public so that can be accessed by the objects from outside of the class. A method created simply to assist a service method is called a support method and should not be declared as public. Now there will be some methods that are only needed within that class. It can be called as helper methods or service methods that are used for a specific task and are only needed within the class for a particular task. Then these kinds of methods are called service methods or helper methods, and these can be declared as private as they are not needed publicly. If we look at this example again, we can see that we are able to access these instance variables from outside of the BMI calculator class. This is the different class, that is the test class that we use to create the objects for this BMI calculator class, and it has a main method, but we are able to access these variables, instance variables, and we are able to change these variables. And now this is something that we do not want when we use object-oriented programming. We do not want to provide direct access to our data to the users or to the client. We only want to provide controlled kind of an access to the user, and we can do this using the private keyword. As we can see, we have not used any access modifier with these instance variables. That means that they have the default access level at this moment, and the default access level in Java is package level access. That is, it will be accessed by all of the classes that are inside of the same package as this class. So we can try to change this, and we can try to control the access to these variables using the private keyword. Now what the private keyword does is it will change the accessibility of these variables. And now if we look at this class, we are getting an error, and the error is the field BMI calculator in kgs is not visible. Now it is not visible to this class now, since we have changed the access of this class. Since we have changed the access of these variables, now we are not able to access these variables from outside of the BMI calculator class. We need to maybe comment out these statements now to avoid this error. Now what it does is that we now cannot change the values for variables directly using the client class. If we look at the output now, we are getting the old output that we are getting with the values that are assigned to these variables. Now ideally we would want these values to be different for each object that we declare for the class, and maybe we would want to calculate the BMI with the different values for the same class as well. For example, if we are able to reduce our weight maybe, and we want to check that if our BMI is now within a reasonable range, we would want to be able to do that through this program, so that we can change our initial value of our weight and we can provide it with the new value, and we would want to be able to see that if we can change the values indirectly for these instance variables. Now we might also want to change this to private, so that we have the same level of accessibility for our variables. We can see that our methods are displayed as public, since we would want to be able to access these methods from outside of the class, so that we can calculate the output or see the output that we are calculating using this formula inside this calculate BMI method. Now if we look back at our car class example that we saw in our previous lecture, we can see that the different objects for the class can have different values for the instance variables of that class. Now this is something that we were not able to do in our BMI calculator class, and we would want to be able to calculate the BMI for different users with different values. We can achieve that using the constructor that initializes the values of each object with the different values for that object. So if we look at the three different objects of the car class, car C1 has different values, like this is a Nissan, it's a Leaf. If we look at the variable names, then the make of this car is Nissan, the model is Leaf, the year is 2010, the speed is maybe it's a 4-speed car. Then we have some other car C2, it has its own different values for these variables, and the car C3 has its own different values for these variables, for all of these variables. And the memory allocation for these variables accordingly is a separate memory is allocated for each object that stores that particular values for that object. So it has its own memory for say one object of the class with its own values for all of the variables. It has a separate memory allocation for the C2 object of the car class with its own values for the same variables. Now if you can see that the variables are the same, but the values inside those variables are different for the different objects of the class. And that is because we are able to we would want to create multiple objects for the same class that would have the same properties but with different values for each object. Now we can achieve this by using the constructor. The constructor allows us to initialize our objects with its own values, and each class in Java has a constructor. We talked about the default constructor, that if you do not explicitly declare a constructor in our class, then the Java compiler defines a default constructor for us that initializes our values to the default values. Now given here are some examples of the constructors that we can declare inside our classes. This one is an empty, this one is a constructor that initializes the variables to zeros. It takes no parameters. Now this one may be an empty constructor. This one is a constructor that takes one parameter, and then it will be able to initialize this parameter to some value. And this one is a constructor that takes two parameters. So we can have multiple constructors inside the same class, and a constructor can be defined, maybe it has two properties that we need to remember, that the constructor is always of the same name as our class name. As we can see over here, it is a function, it is a special kind of a function that is always of the same name as our class name, and the constructor has no return type, like it does not return anything, not even void. So it does not return anything like our normal methods, and it is always of the same name as our class name. Constructors are invoked to create objects from the class blueprint and initialize instance variables. If you remember that when we were creating an object for a class, even when we did not have a constructor inside our class, we were able to initialize the object for that class using the default constructor. We will look at it again in a while. It looks like a method declaration, as we can see, except that they use the name of the class and can specify parameters but no return type. So there is no return type for our constructors. We need to remember these two properties of the constructor, that is, it will always be of the same name as our class name, and that it does not have a return type. It can have parameters, as we can see over here, but it does not have a return type, not even void. It is automatically called when an object is created using the new operator, as we saw in our example, that we are able to create an object for the class using the call to the constructor. And we should note that Java requires a constructor call for every object that is created. So if we do not create a constructor in our class explicitly, what Java does is it calls the default constructor of the class to initialize the object, because Java requires a constructor call for every object that is created. We can have more than one constructors inside our class, and this is called constructor overloading. This is something that we'll be discussing in our future lectures. And each constructor has a different signature. As we can see here or here, the signature of a method is the name of the method and the number of parameters of that method, and maybe the return type of the method. And overloaded constructors have different signatures, that is, they have different number of arguments maybe, or the different number of the different sequence of the arguments inside that constructor. Now let's look at our BMI calculator example again, and we'll see how we can use the constructor to initialize different objects with different values. Currently we have a default constructor in our BMI calculator class, and it initializes these values to the default values if we do not assign these initial values to these variables. Now this is something we will try to avoid in Java in object-oriented programming, and we will try to initialize our objects using the constructor. Now if we declare a constructor inside a class, the default constructor then no longer exists. The default constructor works the same as an empty constructor, and the definition of the constructor, if you remember right, is it is always of the same name as our class name. So these are the first preliminary things that we need to be careful about, that it is always of the same name as our class name, and since it is a special kind of a method, so it will need to have these brackets, and it has its own body. Now this is an empty constructor. This is not a default constructor anymore. There is no default constructor in this class anymore, since we have explicitly declared a constructor over here. So the default constructor does not exist anymore. Now we can change this command to, that is, this is a constructor inside this class. Now ideally we would be using the constructor to initialize our values. If we look at this object declaration, again it does not give us any error because it is the same as calling the default constructor, since we have an empty constructor in our class. As you can see over here, the BMI calculator, it shows us that we have an empty constructor in our class. It does not make any difference that if we do not have a constructor or if we have an empty constructor, so we are not initializing our values through the constructor. Now what we can do over here is we can declare two arguments in this constructor, and we need to be careful that this should be of the same data type for which we are passing the values. And so our constructor now takes two parameters, and if we look at this class now, there is an error because now we cannot use the default constructor or the empty constructor to initialize or declare an object for the class. We must provide two arguments to the constructor so that to be able to create an object for this class. We'll do that in a while. Now currently what we will do over here is we will be using these values, these parameters, to assign and pass the values from the object declaration to our instance variables, and we can do this weight in kgs is equal to weight, and now you might want to perform some basic validation that the weight cannot be less than 0, so means we cannot possibly have someone with a negative weight, and the height cannot be less than 0. So these are the basic validation that we can perform whenever we are tracking values from the user, so that to make sure that we are not taking an invalid value. But at the moment we assume that we are inputting providing the correct values over here, and we'll assign the height that we are passing from the object to the constructor, and we'll assign that height to our instance variables in this class that we have declared in this class. What will happen now is that when we declare our object, these initial values will be overwritten with the values that we have provided, that we will provide over here and at the time of the object declaration. So now we'll change that, and we will provide some initial values to our object. Now we'll try and check if anything has changed. We will run this code, and we'll see if the display method. Now our previous values were these 100 kgs weight and 1.7 meters, and this was the BMI. we'll try to see that if the previous values are overwritten by the values that we are passing through the constructor to the call to the constructor or not, and that will highlight the use of the constructor in object initialization. So what has happened over here is that the values that we provided initially are through assignment operator to our variables have been overwritten by the values that we have passed to the constructor. So this is what will be using the constructor for, and now we do not need these initializations since these will obviously be overwritten by the initialization that we have done through our constructor, and this is how we'll be initializing our variables. And now we can have multiple objects as we saw in our car example for this class with their own set of values. So now we have another object, maybe BMI2, and it will have its own value. So maybe we have someone that is really maybe not happy enough, and then we can call the methods inside the class using the second or as many objects that we declare for this class. We try to differentiate maybe so that we are able to see that we are using two different objects to initialize the values. Maybe if I increase the weight for this one, the height for this one, the first one, and use different values for the second object, so now we can call the methods inside the class using as many objects that we create for that class. We can see that the BMI for the first one is different and the BMI for the second one is different. Now if you have read the lab task or the exercise for the BMI calculation, you would understand that what these different values for the BMI mean, and you can use an if statement to add more information to display that what this BMI value really means. But we can see that we are able to initialize our objects or different objects with different values for the same instance variables using the constructor. Now a default constructor, as we saw that if a class definition doesn't include a constructor method, the Java compiler inserts a default constructor with no parameters, and the class's instance variables are initialized to their default values. And we understand that the default values is 0 for the int variable, it's null for the string, and boolean false for the boolean, and then other variables or data types have their own default values. And this is an example of when a default constructor will be used. So we have the class, we have the variable declaration, but we do not explicitly declare a constructor inside this class. So a default constructor will be declared for this class by the Java compiler. It will be, you can say that, inserted by the Java compiler that will initialize our values to the default values. We should understand that the local variables are not initialized by default. So if we have some values that are declared inside our methods, then those variables will not be initialized by default. But we saw in our constructor that the parameters of the constructors are the local variables of the constructor. and those won't be initialized to default values. It is only the instance variables that are declared inside the class, but outside of the methods of the class will be initialized to default values. And we saw that there is no default constructor in a class that declares a constructor. So once we declare a constructor inside a class, the default constructor no longer exists. And the compiler will not create a default constructor as we just saw in our example.